So yeah, I'm gonna present the main workflows that I've seen from the interviews and surveys in the high-income countries and the partners from the consortium. And I'm also gonna present some interesting results from the surveys. The first thing that I've realized is that there's a lot of variability across the different labs and the different workflows. And that reflects that multiple valid workflows can coexist. And they are different implementations of the standard, maybe procedures of each country. The lab workflows are conditioned by many factors. Can be the budget, as we've seen with low and middle income countries, the prevalence. Maybe if I don't have prevalence for one type of resistance, I will not buy that technology. No. Human resources. There are some procedures that need hands-on time, and if I don't have a lot of technicians, maybe I'm not able to do. The space, the expertise of my human resources, and the number of samples that I need to process. And then, of course, the reimbursement. Thierry was talking yesterday about reimbursement of screening in France, which is not reimbursed. They told you that you need to do everything you can to screen and isolate, but they don't give you the means. Okay, the arrows are not correct. As Katalin said yesterday, that looked good. Chez moi. But okay, anyway. What does the blood traditional workflow look like? We start with a blood culture, and it's positive between 72 hours. Most of the infecting bacteria are positive the next day. Then we do the gram stain. Well, I don't. They do. A culture, overnight culture, and then identification with biochemical tests. And finally, the AST. That takes about 3-4 days, which is too late for some patients. But then with the rise of modern microbiology, that has changed, especially with the MALDI-TOF. Before the pre-MALDI-TOF era, we had to do the overnight incubation to identify bacteria, which is the case in low and middle income countries. But with the MALDI-TOF, we look at the proteins, and we have these fantastic graphs from the mass spectrometry. And at day 0, we can identify. And that's even better, if we do the pellet, as we've seen. It's a pure bacteria concentration, and we can do the gram stain, the MALDI-TOF identification, direct AST, a PCR for methicillin resistance as Aureos, for example, and, as we've seen, a lateral flow immunoassay in less than 30 minutes. The pellet, as I put here, bypasses the incubation. In this paper, they showed some images between gram stain before pellet and after the pellet. And that was really interesting for me. I saw that the definition of the bacteria has increased, and you can differentiate them better. And even NG Biotech is selling for the Carbo-5 some buffers to prepare pellets and test directly from sample in the current lateral flow strips. So that highlights the importance. Okay, again, the arrows went. I identified 2 main blood workflows in the consortium. At the top, you have the ones that use a pellet for the MALDI-TOF identification, which takes about 15-30 minutes to prepare. Then you identify with the MALDI-TOF, and you directly perform a resistance with lateral flow, with a turnaround time of 1 hour after the positive blood culture. And you can do a direct AST, so that's a very fast workflow. Then we have other labs that prefer, or maybe they are not able to pellets, or they don't rely a lot on pellets. That hasn't worked for them, and they do a short culture, which takes about 3-4 hours. Then they identify, and they can do the phenotypic resistance detection with a turnaround time of 4 or 5 hours, or other labs might do a long culture. So where would the AMR detect tool fit here? Well, when being asked, microbiologists that use a pellet, they said that they would use it after gram stain or after identification, because it's a rapid identification, so maybe waiting 30 minutes is not that critical and doing the resistance test. Some other labs might prefer continue using the classical strips, so that depends on the lab. By using the detect tool after the gram stain, they would detect the resistance like 30 minutes earlier, whereas labs that do a short culture, they would also use the AMR detect tool after the gram stain, and it would be detected 4 or 5 hours earlier. For urine, we need to differentiate two different conditions, as we saw yesterday. There's the UTIs, urinary tract infections, which usually we are not in a rush. It's not a very critical situation. So for screening, usually labs use a dipstick. Then the gram stain, they put on plates. And if there's growth, then they identify with Malditoff from colonies. And then they perform the AST. Then there's a more critical situation, which is a urosepsis, which is a sepsis with origin from the urine, some bacteria that have reached the bloodstream, or a pyelonephritis. The screening techniques here vary a little bit. Some labs use flow cytometry, others just dipstick or the gram directly. And then they perform a culture, identification, and then resistance tests. Not all of them, because some of them run in parallel blood samples as well. So here the AMR detect tool is more likely to be used again after the gram stain for UTIs, as well as for urosepsis, pyelonephritis, for gram-negative bacilli mainly. If it's a gram-positive, as we've seen before, if we have the vancomycin, maybe it will be more that test. As for rectal swabs, there are also two different situations that I've realized from the interviews. We have the high-risk patients that get to the hospital for the first time. High-risk patients, for example, people coming from a country with high prevalence or coming from another hospital. These patients are put under isolation with a dedicated team, which is very costly. So labs usually want to know fast if there's a resistance that they are carrying. So they usually use PCR, which is one of the fastest methods they have right now, and expensive as well, to be able to de-escalate the measures and save costs if it's a negative test. Then we have the routine screening in the SCUs that some labs, for example, perform 2-3 times a week for surveillance of the different genes and enzymes. And what they do usually is selective chromogenic agars, because they are not usually in a rush in these situations, so they can afford this time. So if it's positive, then they might detect the resistance to know the type of enzyme for surveillance purposes. If you know the type of enzyme, and you know that 2 or 3 neighbors have the same resistance with the same bacteria, then maybe you are in an outbreak, right? So that's the importance of knowing the enzyme in this situation. So 2 types of situations. One, we are more in a rush. The other one, not so much. So when being asked about the detect tool, the first situation was very clear. If the performances are very good, labs may switch from PCR to the detect tool. Although the market here is a little bit lower, because you just screen these patients once they arrive at the hospital one time. And then you routinely screen once they are hospitalized. The other situation, which has more market, some clinicians said that they were not in a rush, so maybe the detect tool doesn't bring much value in this situation. Although if the clinical performances are better compared to chromogenic agars, they may switch. And I think it's also important to talk about the prescriber workflow. No? the sample flow, so these other workflows. Let's say we have a positive blood culture at noon, we have the AMR results at 1. Probably there's not going to be a problem. There's going to be a technician that can do the gram and the AMR test, and there's going to be a clinician that can de-escalate or escalate the treatment. I put de-escalate in green because it's something you want to do, not to fight AMR. And also what microbiologists mention is that for very severe patients, usually broad spectrum antibiotics are given to cover gram-positive and gram-negative bacteria. So it seems that de-escalation would be frequent in this group of patients. But let's put another situation. Let's say we have the positive blood culture at 8 in the evening. The results are available at 9. First, is there a technician in the lab that can do the gram and the test? Some labs are open 24/7 hours, but some may not. And then, even if yes, is there a clinician on duty that can adjust the treatment? Because if there's no clinician on duty and they wait for the next day, maybe they'll say, why would it need a rapid result if I need to wait overnight and I can do a culture? So we would lose here the advantage or the speed. So I think this is an important topic that you can discuss in the design thinking workshop about your laboratory organization. Now I'm going to present some interesting results from the surveys. This is the average number of tests that the partners of the consortium, the clinical partners, do. So we have ESBLs in blood per week. They do 13, urine 12, and rectal swabs 62. Whereas for the CARBA, 10 in blood, 9 urine, 52 in rectal swabs. So we have a total per week of 23 for blood, 21 for urine, and 114 for rectal swabs, which gives a total of 158 AMR tests per week per hospital. The first conclusion that we get from this table is that the rectal swabs is a bigger market because more tests are done. But it's also the most challenging one because, as we've seen, we have one situation which is where we need speed, and the other one it's not so clear, no? So we'll need to see. And then the price of the chromogenic agar is also a challenge because it's very cheap. So again, talking about the price of the AMR. When being asked about the price, clinical partners answered the maximum price that they were willing to pay. And the average was 13 euros and 30 cents for the AMR detect. That was the price that came up. Regarding the new test, vancomycin AMV, for the question, would you be interested in VAN-AV tests? 67% of them said yes. For which samples would you use it? Combination of blood rectal swabs was at 60%, just blood 20, and blood and urine, it was at 20%. As for the OXA23 Acinetobacter, was a similar rate for yes and no question. And then for which samples we see a lot of heterogeneity, a perfect cut. So these are the combinations that the labs, that the samples that they would use the OXA23 test. We have the bronchoalveolar lavage here as well, that Roger mentioned that you're working on that. So to sum up, which are the main use cases of the AMR detect tool? Well, microbiologists all agreed that when a fast result is needed is when the detect tool brings more value. Which are these cases? Well, septic patients in the ICU, urosepsis, high-risk patients hospitalized in case of an outbreak, although they're not so common, at least in Europe. And here I open the question, are there other settings where the AMR detector could be used? maybe as a POC near the bed of the patient. That's another topic that you can discuss in the design thinking workshop. The economic study will be of great importance to show that maybe if you invest just a little bit more, the savings will be much higher in length of stay reduction, or you use less antibiotics, etc. The literature shows that there is a high economic value. So these preliminary results are in favor of the use of AMR detector. And the main added value, as we said, is the speed and the cost, especially compared with the PCR. So thank you. That was all.